Morals, thank you for subscribing. Gabo, thank you so much. Jay Hay, thank you so much. User, thank you for subscribing. Yes, I have captured CMEs live on TikTok. Thank you, Tracy, for the subscriptions. Thank you so much, Tracy. Hi, Cosmic Goddess. Welcome in. Thank you all for subscribing to my channel. Thank you so much. This is a filament where the sun's magnetic field is reaching about 20,000 miles high. Well, welcome in. You're looking live at the sun. Now what I'm going to do, everyone, is I'm going to zoom out and we're going to switch telescopes. We're going to go to my blue telescope so we can look at the surface better. So what's going to happen here is we are going to look at the sun through a different filter. This one was really good at showing some features, and this other one is better at showing sunspots and the surface of the sun. So we're going to look deeper into the sun with this filter. So the sun isn't one temperature. So having multiple telescopes helps me be able to show you more of what's going on with the sun. So let's get this going. Come on, camera. Welcome in, everyone. You are not looking at Neptune. You are looking at the sun in blue light. This filter looks at the hottest regions of the photosphere of the sun, what we would consider the surface. Welcome in, Zeus. Thank you so much. Welcome in, everyone. You are looking at the sun. Ravens, thank you. Rob, thank you. Zeus, thank you. Big shout out to Isabel and Tracy. Thank you so much. Welcome in, Little Miss Butterfly. Thank you so much, my friend. Thank you all for supporting my channel. I am going to be doing a donation to the AOA. Thank you so much. To the Denver Public Schools. I'm going to be taking money for the next couple months, adding it all up and buying eclipse glasses that I will donate to Denver Public Schools for the April eclipse. We are in a period of higher activity. It's just not extreme. Valerie, thank you so much. Thank you all for subscribing to my channel. It's greatly appreciated. Gold is extremely rare. Every element above iron on the periodic table, it gets rarer and rarer the heavier it is. And this is because the only places where those elements are created are in the death of giant stars. When those giant stars explode, that's where those elements get created, or when the cores of those stars, which are called neutron stars, collide. So they're very yes, this is a sunspot. So welcome in, everyone. You are looking at the sun. Uranium is one of the rarest elements. I don't know what the rarest element is.
As long as skies are blue.
I think the rarest element is astane. It's the element At. It is its atomic weight is 210. And the reason why it's so rare, its half-life is only 8.1 years or 8.1 hours. So it dissipates so quickly that it doesn't exist very long. Dev, welcome in. The element of surprise, Colt. You're absolutely right. Gnarly, welcome in. I definitely, my personal belief is the universe is full of intelligent chemical life, but we have no evidence of that. And that's why I preface that with my personal belief. My personal belief is not evidence. And you can't prove things logically without demonstrable evidence. So we can logically assume that life has probably exist on other worlds, but that's not physical evidence. Thank you, Tracy. Yes, all the new subscribers DM me for a link to my subscriber-only Discord server. Thank you, Eddie. Welcome in, Tracy. You humble me. Thank you so much. Yes, Magic, any additional kind of life would be fabulous to see. This is the sun, and I'm going to show you the sun through a second filter. This is the sun in green light. JT, welcome in. Eddie, welcome in. Now we're looking at the sun. Angela, you're most welcome. Welcome in. Rosie, is the sun local? What do you mean by local? And do you know why flat earthers call the sun local? Because they know the sun is not local. Local does not mean anything. If I said I'm local to you, what does that mean? Am I a mile within you? Am I 30,000 miles within you? Am I a billion miles away? Local is not an answer to a distance. How do we determine the distance to the sun? Well, the sun's distance was first measured in 150 BC, and they were within 98% of accuracy from today's measurements. That's pretty astounding. How did they do it? They used this type of math called geometry. Literally, 7th grade geometry will tell you the distance between the Earth and the Moon and the Earth and the Sun. We can simply use triangles or a process called parallax to measure the distance between the Earth and the Moon and the Earth and the Sun. And the ancient Greeks knew this math. They called it parallax. And the Greeks thought that the stars would show parallax, but they had not developed telescopes that you need to see parallax of stars. So we know how far the sun is away using just basic 7th grade geometry. Welcome in. Now I'm going to show you the sun in black and white. This gives us a better view of, you can see the grain of the sun. Those black dots are sunspots where the sun's magnetic field pushes away the hot plasma, creating a colder region. Welcome in, everyone. Eddie, thank you so much. Good afternoon, Rebecca. Awesome to see you. Welcome in. So all stars produce the same elements. So one question we get in science is everything in the universe made out of the same stuff? Yes. The light from distant stars and galaxies and gas clouds all show us the spectral And we use spectrographs. It's a type of science that we use to determine what things are made out of. That spectrographs show us what the sun is made out of, or a distant galaxy. And guess what? Everything in the universe is made out of the same stuff: electrons, protons, and neutrons. And there's other things, but matter is generally those three elements. Now, there are a lot of neutrinos and other subatomic particles, but for everyday life, these are the elements that are the subatomic particles, or the elements. Loon, thank you so much. Welcome in. Welcome in, everyone. Welcome in, everyone. You're looking at a live image of the sun. Now, what I can do is I can turn up the volume here, and we can see we have a couple prominences or filaments. This is where the sun's magnetic field is lifting plasma off the side of the sun. Like right here. Parallax is measuring something from two locations at the same time and seeing its relative different position from those 2 points of view. Welcome in. This is a gas cloud reaching up, a plasma cloud about 60,000 miles. Welcome in. I think titanium is stronger than tungsten, but I am not a chemist, so I can't really tell you what the strongest metals are. Welcome in, everyone. You're looking live at the sun. So I like showing you these white regions are with scars on the surface of the sun that are hotter. These are where the magnetic fields of the sun opened up the surface and created these scars, and they're called plague. My nephew asked me, will we be ever be able to go to the sun? Artistically beautiful. I don't believe you will ever be able to make it all the way to the surface of the sun, but we've been within about 3.8 million miles of the surface. Science doesn't make a claim on how the universe started. We know that the universe was in a small, dense region, but we don't know what existed before the expansion of the universe took place. So the science doesn't say this is what happened before we have evidence. All science says is something else. We don't know. So the concept of not knowing is science just simply doesn't make a claim without having evidence. But science does not make the claim that the universe came from nothing. Definition, and nobody in the universe has ever seen nothing. So it is an invalid claim to say it came from nothing, because we don't even know what nothing is. There's always something. Welcome in. Oh, did we get another bird? Raven, we don't know because we haven't seen the evidence. We don't know. So rather than talk about what we don't know, we try and talk about what we don't know. People who say science is always disproved by more science. Yeah, that song, Soak Up the Sun. Yeah, this is my sun playlist. Hi, Michelle. Welcome in. So, thank you very kindly, Molly. I'm so glad you enjoy it, and I'm glad you enjoy my work. Thank you, Parker. Hey, Parker. Welcome in, my friend. Thank you for having me up on your live. I greatly appreciate that, Parker. Everyone, I want, yeah. So everyone, this is Parker. He is a debate host, for lack of a better term, and he does a lot of challenging people's positions, and he does it very respectfully. He hosts an amazing live, so if you're interested in debates on all kinds of different subjects, go check out my friend Parker. He does a fabulous job. Thank you so much for having me as a guest. What you're looking at here is the sun. And Parker can teach you all. He's always got great hosts and great content. And I don't know him very well, but I consider him a mutual and a friend. Thank you so much. Welcome in, everyone. You are looking at the sun, and you're looking at it in blue light primarily. The sun does rotate. It rotates on the equator once every 26 days. Now, here's the crazy thing about the sun. You would think all of the sun rotates around itself at the same speed. No. The closer you get to the poles, the slower it rotates. So when you get near the North Pole, it takes 31 days. At the North Pole and the South Pole of the sun, it takes 38 days right around there. Why would the sun not rotate the same way as the Earth? Well, the Earth is mainly solid rock in the crust. Well, the sun is not solid. There's no solid on the sun. There's no liquid on the sun. There's no gas on the sun. The sun is the fourth state of matter, plasma. So you can't make water or rock or anything other than plasma on the sun. The sun is so hot that you can't put a metal on the sun and have it stay solid liquid. It would evaporate into plasma. Welcome in. So what you're looking at here are sunspots, where the sun's magnetic field punctures the surface. Well, what's happening here is this sunspot is twice the size of the Earth, this large sunspot. This small sunspot is probably the size of the Earth, to put size into perspective. These magnetic fields get twisted because of the rotation of the sun, and it's like winding a rubber band. At some point in time, you can't wind a rubber band anymore. It's going to snap or unwind. And that's what's happening right now on the sun, is these magnetic fields are unwinding. And the unwinding of these magnetic fields cause that energy to be released. And this particular region, this magnetic field, is pushing the material over. Serial Killer, welcome in. Thank you for coming in. It's always a pleasure to see your name. You always make me smile. And these magnetic fields create flares and create prominences and filaments and sunspots. So the sun is dynamic and always changing. Waza, welcome in. So they're twisting because of the plasma that generates them. And then the plasma starts rotating in another direction because the magnetic field starts twisting the plasma. So it's this chicken egg thing going on where the plasma gets twisted by the magnetic field, and then the magnetic field twists the plasma. So they're always going through this. The sun has an 11-year cycle, and we're entering solar maximum. And the solar maximum, actually, what I'm going to do is go to the green channel. This is the color of the most common color of the sun. Zeus, thank you so much. C. Blake, welcome in. So what causes the magnetic field? Let's talk about magnetic fields. So if you're familiar with a bar magnet, it produces a magnetic field because all the molecules line up. And because they all have polarity going in the same direction, they create what we call a magnetic field. If you remember in school, if you did the experiment, you would put a magnet, then a piece of paper, and then iron filings. And all those iron filings will create loops. These loops are what we call magnetic fields. Well, how does the sun do that? There's no bar magnet there. Well, plasma, because all the gas is missing electrons because it's too hot to hold on to electrons, creates a magnetic field. So these molecules line up, or these plasma line up, and when they line up in certain configurations, they create large magnetic fields. To put it in perspective, the sun's magnetic fields stretch out of the sun and go all the way past Neptune and Pluto, and then all the way back into the sun. So the sun's magnetic fields are literally millions of times more powerful than the Earth's magnetic field. Jupiter has the second biggest magnetic field, and it stretches all the way to Saturn. So these magnetic fields are caused by rotations of charged particles. So why does the Earth have a magnetic field? Well, deep in the Earth is a liquid iron plasma, or liquid iron. And this liquid iron is magnetic, and it lines up because it's liquid, and it's rotating because of the Earth's rotation every day. That creates that magnetic field. So the sun's storms, like these magnetic storms I'm showing you, and these sunspots are all caused by magnetic forces, not from heat. They're caused by magnetic forces. Welcome in. Elliot, welcome in. I want to thank everybody for coming in. I hope you're having a great time. And Micro Fluff Seal, keep coming in, and I will keep explaining it in again and again different ways. And people get to learn how the sun works. Don't feel bad if you don't understand. It takes a long time to learn this. Why does the Earth spin? Because an object in motion stays in motion until a force acts on it. There is no force acting on the Earth to make it slow down. What is dark? Oh, look at that! Did you guys see that? That was a bird. That was awesome. Riley, welcome in. I've got more birds going through this in airplanes than I normally do. Those dark spots are sunspots, where the sun magnetic field cools those regions. Those regions are hot. You know, you see this dark sunspot and you're like, what is this dark sunspot? Well, this dark sunspot is not dark. So I'm going to explain two things at once. I'm going to explain sunspots and darkness. Darkness is a human construct. It is not a physical thing. What you might consider dark and an owl considers dark are two different things. Dark is a relative term based off how much light something has. So there is no scientific definition of dark. So that is important to understand. These sunspots are darker, meaning they have less light coming out of them than the surrounding areas. And that is something we can talk about, is the relative difference between light and dark. So the light coming out of the regions around the sunspot are 10,000 degrees. The sunspots are about 7,000 degrees. Oh wait, 7,000 degrees is dark? No. if I could magically pick out a sunspot and put it in the night sky, it would be 1,000,000 times brighter than Sirius, the brightest star. It's because they look dark because of everything around it. Remember, we talked about dark being relative? Well, that's what that term means. So they're dark only because everything around them is brighter. Welcome in. We are looking at the sun in green light. Yeah, the birds are showing up in droves. I am going to have to download this video and maybe make some videos with stars with there. So India is not going to land on the sun. It is going there to investigate the corona, and it's going to touch the corona. Oh, I'm sorry, serial killer, that it's gloomy. It's going to be gloomy here on Wednesday. We're going to get rain, maybe a little snow. Oh, another bird went across. Welcome in. Parker, thank you for coming in and hanging out. Is it true Saturn's rings will not be visible from 2025 through 2032? No. For about a month of 2025, Saturn's rings will not be visible. They're not going anywhere. But imagine if you know what an LP or a CD is. If you look at it when it's tilted, you can see a lot of the CD. But if you look on it edge on, it disappears almost. Well, imagine that Saturn is 850 million miles away. The rings are about a mile thick. So when they're edge on to us, they almost disappear. So most amateur telescopes will not be able to see Saturn's rings for about a month. And then Saturn's rings will start tilting as it and the Earth change their equatorial planes, so they're not on the same plane, and then they will twist greater. It does this, I think it's every 15 years. I got to look it up and do a video on this, because there are some really crappy news articles out there that they're saying scientists are saying Saturn's rings will disappear in 2025. Yes, we are, but we're not saying they're disappearing. They're not going to be visible. Welcome in. We are looking at the sun live from Denver, Colorado. Poetic, welcome in. Thank you, Alexis. Welcome in. Yeah, we're getting lots of birds. Oh, look at that bird. Oh, wow. Cinderella, I'm doing well. How are you doing? Welcome in. Oh, look at this bird. I think it's the same bird, and it's just, I'm in the perfect spot. Jesse, thank you so much. Welcome in, everyone. You're looking at the sun. The birds are birding today. Hola, Leela. Welcome in, everyone. Cinderella, thank you so much. Thank you all for the gifts. Welcome in. That's awesome. And feel free, everybody, to swipe the comments away. Take screen captures, video captures, and make your own videos. I used to go to everybody who ever tagged me in a video, but I have one video that has over 100,000 tags in it and over 100,000 comments. So I had to turn notifications off. If you're a subscriber or follower and you really want me to see your video, send me a DM of your video and I will check that out. Hi, Kate, welcome in. Does the sun get brighter to Earth? No, the sun over 1 million years will get less than 1,000,000% brighter. Now, in about 1 billion years, the sun will get 5 to 6% brighter because of changes in nuclear fusion, and the sun will get bigger and hotter, and it will be bad for the Earth. So we have 1 billion years before we need to start worrying about that. Free fall. hurry back, and thank you so much. Feel free to ask questions anytime you want about the sun. We are looking at the sun. I'm just changing the filter to the blue. Oh, look at all the birds. What's going on? I must be right where they're creating. Hey, Patrick, welcome in. So, yeah, the birds are probably right where there's a thermal, and they're probably riding the thermojets getting higher. Welcome in. You're looking at the sun, and we're looking at it in a calcium K filter. This telescope configuration is about $3,000. A lot of people don't do this. I think I'm the only person who has this. No, there's one other person who has this. Carbon, welcome in. Those could be eagles. We do have bald eagles in the area here in Denver. Thanks, Coca. Yeah, the sun is always this blue. We are looking at the hottest, the most energetic form of visible light coming from the sun. This allows us to look deeper into the surface of the sun. And today, the sun is attracting a lot of birds. Porter Pop, how did you measure the distance between the sun and the moon, or are you just saying the sun is not 93 million miles away? I would like to see your method for measuring. Lady, welcome in. Yeah, the birds are really close to the telescope, and the sun is very far away. They're space birds. I love that, Para. Thank you. Welcome in. The sun is on average 93 million miles away. So how did we get 93 million miles away? Is simple. So first, we want to measure the distance between the Earth and the Moon. And we use a technique called parallax, where we have two observers on the Earth. We measure the distance between the observers, and then we measure the angle of the Moon relative to stars from each other's positions. And guess what? They're not in the exact same spot. If they were in the exact same spot, the moon would be really, really, really far away. The more they move, the closer the moon is. And what I want everyone to do so they understand parallax is take your hand and take your index finger and stick it all the way up at arm's length. Then cover your left eye and your right eye. And what you're going to see when you use only single vision, you can see the finger move back and forth. This is how your mind judges distance, is using parallax. Well, we can use parallax using the Pythagorean theorem, a squared plus b squared equals c squared. Or we can use 8th grade trigonometry and use the sine and cosine. We measure the angle and the distance. That gives us the hypotenuse of the triangle. When we do that, anybody who does this experiment ends up with the moon being approximately 240,000 miles away. Now we know the distance between the Earth and the moon. How do we find the distance to the sun? Well, guess what? The moon, every 29 and a half days, will be first quarter moon, where half the moon is illuminated and the other half is dark. We call this phase first quarter. Well, we know the moon is perpendicular to the sun. At that point in time, we measure the sun using parallax, and guess what? We draw that triangle and we get 93 million miles away on average. So we can use simple geometry and trig, if you want to make it even easier, to measure the distance between the Earth and the moon and Jupiter, or not Jupiter, the sun. We can also use Venus's phase to do the same type of triangle, and it again works and gets us 93 million miles on average. Why do I say on average? The Earth is going around the sun, but not in a perfect circle. It's a squished circle, what we call an ellipse. And the ellipse that the Earth is in, sometimes the sun is 24.4 million miles away, and sometimes the sun is 92.5 million miles away. So if you've ever heard someone saying, if the Earth's orbit was any different than 6 inches, we would fry. We go back and forth more than 1 million miles. We can also, scientifically, we can bounce radar off the sun. And when we do that, we get a more accurate reading than our geometry. But we're still within tens of thousands of miles with the geometry. Welcome in, everyone. You're looking live at the sun. I hope that makes sense to everyone, how we measure the distance. Thank you very much. You are most welcome. It was my first time ever on Parker's channel, and it was an awesome experience for me, and it was nice meeting Parker as well. Hopefully we do some other things together, but I appreciate his opportunity to do this. So the Earth does get closer to the sun and further from the sun, Michael, by over 1 million miles. Now, you want to know something wicked cool, everyone? The Earth is moving away from the sun. Nature, thank you so much. So, I don't always read all the comments because I start talking and I talk with my hands and I get up and walk around. So let me tell you something wicked cool. The Earth is moving away from the sun. What? How can it be moving away from the sun? The sun is on a weight loss program. The sun converts hydrogen into helium, which creates energy, photons. And those photons escape the sun. And it's converting 4 million tons of hydrogen into helium a second. 4 tons get converted. Well, that's weight loss. So the sun loses a little mass every second of every day. And that equates to the Earth moving away 6 inches a year from the sun. So it's not a lot of distance, but given billions of years, the Earth is moving away from the sun 6 inches a year. We're still in that elliptical orbit, but that orbit gets a little bigger every year by 6 inches. Does the moon move away? Yes, but the moon moves away for a different reason. We have birds all over the sun right now. Actually, they're in my sky above my telescope. So, 6 inches is what I said. That is not what she said. Welcome in. No, we are spinning. The Earth is 4.5 billion years old. There's multiple tests of it. Hey now. Oh my. So, no solar flares right now. We do have lots of birds flying between my telescope and the sun. Welcome in. All right. Welcome in, Atlas. Thank you. What were we talking about before somebody made me laugh with the 6-inch comment, even though I was talking about 6 inches? Oh, the moon moving away. What causes the moon moving away? The moon is moving away because of the tides. So as the moon pulls on the Earth's oceans accelerate the moon. And the moon is not just moving away and causing the tides, it creates friction. That friction is slowing down the Earth. So Earth's day 4 billion years ago was 8 hours a day. Can you imagine that the Earth was spinning 3 times faster than it is now? And we can see that it was doing that in the geologic record in rock formations that formed around tidal regions. We can see that the tides were much larger and faster. So we do have leap seconds, or we add time to clocks every once in a while because the moon is moving away about 2.5 inches a year. And that is what he said, 2.5 inches. Eric, thank you so much. Eric, thank you. What would happen if the Earth stopped spinning? You can't make the Earth stop spinning without stopping it. And if you did, you would lose a lot of storms. You would lose the jet stream. You would lose a lot of wind. And one side of the planet would freeze. If the Earth stopped spinning, one side would be facing the sun for months, and the other side would not get any heat. That part would freeze. It would be a really, really weird, difficult world. Does the Earth moving from the sun make it cooler? Billionths of a degree cooler. Temperature on Earth is more about the thickness of the Earth's atmosphere than the sun. The sun delivers the same amount of energy every second of every day, but the Earth's atmosphere and what's in it determines the Earth's temperature. Welcome in. Hey, Sal, welcome in. Welcome in, everyone. You're looking at the sun. We're talking about the sun. Will the moon reach maximum and then start getting closer? No, Gary, in about 4 billion years, the moon will probably wander away. It will get so far away from the Earth that it will probably wander into the solar system. Welcome in, Tracy. Thank you. Becca, wow. Welcome in. Good to see you. Alexis, thank you for the glasses. Saint, we most definitely can. I don't want, Parker is a new friend of mine. We will, we'll have to talk and see if he wants me to come back up sometime. I'm more than willing to talk on Parker's lives and discuss topics. Hi, Steve. Welcome in.